discussing organic chemical technology course. In module 1 we discussed about the introduction to chemical process industry in lecture 1, and in lecture 2 we discuss about the raw material for chemical process industry, and in the third various unit process and unit operation which are being used in the chemical process industry. Now we will be discussing module 2. In the module 2 contains 3 lectures. Lecture 1 that will deal with the coal and coal as chemical feedstock for the chemical process industry. As you know, the coal is the major source of energy. It provides 25% of the total world energy consumption and generates 40% of the world's electricity. There has been continuous development in the utilization of coal as source of oil as substitute of petroleum based fuel and chemical feedstock since beginning of the 19th century, and again gaining importance due to rising cost of crude oil and limited oil resources. Most of the chemicals derived from the coal was by destructive distillation of coal, furnishing mostly aromatic and acetylene route using coal and limestone. However, with the advancement of technology, many other chemicals are being made from the coal. Now, coal being considered future raw material for fuel and chemicals through synthesis gas along with its major use as primary source of the energy. One question comes to mind, why coal as a chemical feedstock? Because you see the coal from very beginning of the 19th century, before coming of the petroleum and the petrochemical, the coal was the route from which we are producing many of the chemicals, especially the aromatic, even some of the inorganic chemicals were also produced from the coke oven plant. So, this was the route, and this is the reason why the again the people are having the interest. Even the coal to liquid technology during the 1930, German they worked on the production of the gasoline from the coal, but only because of the economical reason and with the availability of the crude and petroleum, the process was not actually commercialized. As I discussed earlier, the coal is the largest source of energy all over the world and the power production, but the other routes where we are using the coal, that is the synthetic fuel, that may be in the form of the gaseous liquid, coke production, that in the coke oven plant where we are producing the coke from the coal, and during the production of the coke we are generating coke oven gas. Chemicals which are now being derived from petroleum and natural gas route, that can be produced from the coal through the synthesis gas route or through the calcium carbide route. Recent development in utilization of the coal gasification, that is being used as a fuel from the synthesis gas to the FT synthesis and the fertilizer feedstock. Already we are having the 2 fertilizer plant based on the coal during the initial stage of the development of the fertilizer industry in India. That was the one in the Ramakundam, another was in the Talcher, but because of the economic reason these 2 units, because they were the low capacity, that has been closed. Coal to synthesis gas, that is the ammonia and the other chemicals that we are making from the synthesis gas. Synthesis gas means when we are taking the hydrogen, nitrogen from the synthesis gas, then it is going through the fertilizer plant for the making of the ammonia. And as you know, the ammonia, that is one of the major feedstock not only for the chemical fertilizer industry, also for the chemical industry. Coal to oil through the FT synthesis, as I told you earlier also, that the coal to oil through FT synthesis, lot of the work was done during the initial stages, but only because of the economic reason the process could not be commercialized. But again there has been recent interest on this. Coal to methanol and olefin technology, that is coming in a big way, from the coal gasification to synthesis gas to methanol, and methanol to olefin technology, that is the MTO technology, methanol to ethylene. Coal to dimethyl ether through the methanol route, that is also getting important because dimethyl ether that can be directly blended with the gasoline. Coal to plastic through the methanol to olefin technology, because during the process we will produce the propylene and propylene to plastic, or even the ethylene is also produced in the process. And so the coal to plastic technology, already China, they are going to have a plant based on the coal to plastic technology. Coal and coal as chemical feedstock, these future technology are likely to play important role in providing the alternate feedstock for chemical industry. Let us discuss now about the, in very brief, about the coal origin and the composition. Coal is the carbonaceous solid black or the brownish black sedimentary rock matter. Vegetation, biological changes originated from the accumulation of the partially decomposed vegetation. Formation of the coal started 250 to 300 million years ago, and that had taken long time. In the coal which you are seeing now in this form, that took around 250 to 300 million years. Biological changes and subsequent effects of the temperature and pressure altered these deposits to coal. Coal is composed of chiefly the carbon and other elements like hydrogen, sulfur, oxygen, nitrogen, moisture, non-combustible inorganic matter containing silica, iron, calcium, magnesium and mercury. Mercury now again, earlier the problem of mercury emission that was not there from the thermal power plant, but in many of the coals the amount of the mercury that is very high, and the mercury emission that has been reported in the thermal power plant. So, the mercury again is a problem in case of the especially thermal power plant. So, for the coal composition, as you are seeing here, we are having the carbon and hydrogen. Apart from this, some of the undesirable part is also there, that is the sulfur, which is creating a lot of problem, because the coal is, the sulfur content in the coal is varying widely from one place to another place. Just if you take the case of the Assam coal, that is containing very high sulfur, and the other matter which are creating problem, that is the silica, iron, calcium, magnesium compounds, they are coming as after the burning of the coal or the gasification of the coal. So, that is a big problem in case of the where the ash content is high, as in our country the ash content is very high, that is varying from 30 to 40% in major coal reservoir. Coal is highly complex and heterogeneous substance. Coal has a wide range of composition. The composition, sulfur content, mercury content, calorific value of the coal vary widely from one coal reserve to another coal reserve. Coal may be hard or slightly softer depending upon the source. Assam coal is much softer than the other coal, and so that was the problem in utilization of the Assam coal in the initial stage when we try to use the Assam coal in the boiler. Coal resources. Category of the coal resources are based on the degree of assurance, that is the coal reserve, proved reserve, indicated or inferred, or the depth range. So, these are the two bases for the categorization of the coal resources. Let us discuss the definition of the proved reserve or the indicated reserve. So, proved reserve, the coal resource which has been reliably estimated and can be recovered economically. So, that we call it, that is coming in the category of the proved reserve. Indicated reserve means coal resource based on the combination of direct measurement and reasonable geological assumption. Then the inferred reserve, coal based on the assumed continuity of the coal beds. Depth range determines the economy of the extraction and the scope of the exploration. Composition of the Indian coal and coal in other countries, if you compare the ash content, that is very high in Indian coal, that is around 30 to 40%, in other country the ash content is less, sulfur content is here also, although it is less in compared to ash content in other country, carbon 25 to 30%, any other country the carbon content that is high, hydrogen less than 3, calorific value is also less than the in the coal, Indian coal especially. Coal reserve, world's proven coal reserves are estimated at about 860 billion tons, which is expected to last for about 120 years at the current level of production and utilization. The global coal reserves consist of 50% anthracite and bituminous coal, 30% sub-bituminous coal, 70% of irregular lignite. Largest coal reserves of coal are in China, USA, Russia, Australia and India. India has the 5th largest coal reserve in the world. Of the total coal reserve, nearly 88% are non-coking coal reserves, while tertiary coal reserves account for measure 0.5% and the balance is the coking coal. Coal deposits are chiefly located in Jharkhand, Odisha, Chhattisgarh, West Bengal, Madhya Pradesh, Andhra Pradesh and Maharashtra in India. Coal reserves from India up to the depth of 1200 meters have been, that is not 120 meters have been estimated to be 276.81 billion tons as on April 1, 2010. The global coal production in 2011 was 7 billion tons, of which China accounted for approximately half of the production and consumption. And this is the reason how now the coal in China that is being also used for the production of the chemical. Total coal production in India during 2009 and 10 was 532.2 million tons. Lignite production in 2009 and 10 was 23.95 billion tons. Lignite reserves in the country have been estimated around 39.9 billion tons as on March 31st, 2010, and major deposits are in Tamil Nadu. In Tamil Nadu, some of the plants are there which are using the lignite as a source of power and as the source of chemical. This is the status of the coal reserve in India: coking coal, non-coking coal, tertiary coal, and the total coal that is the proved indicated in for a coal demand projection in the 11, 12, 13, 14, 15 plant. These are the some of the figures that is available, and so you can get an idea about the what is the coal demand during the next few years. This is the distribution of the coal reserves in various states: Andhra Pradesh, Arunachal Pradesh, Assam, Bihar, Chhattisgarh, Jharkhand, and then the Madhya Pradesh, and these are the proved indicated in for and the total and the amount of the coal that is given. So this is the coal reserve we are having in India. The figures, there are some variation that may be there depending upon the source, and coal reserves in the sedimentary rocks, that is the Gondwana coals and the tertiary coal. This is the figure that we are getting. This includes the 456 million tons in inferred resource established through mapping in the northeastern region. Coal letters of assurance that has been given to the power, iron and steel sector, small and isolated plant, cement plant, ultra mega power projects, and this is the total blocks that has been given the letter of assurance. Coal bed methane, there is decent interest in the coal bed methane, because coal bed methane is an environmentally friendly clean fuel similar to the natural gas. Preliminary activities related to exploration of the CBM in India started in early 1990, and till 1997 the Ministry of Coal had allotted some coal bearing areas of the CBM exploration. As of the now, about 25 CBM reserves have been established in 5 CBM blocks. CBM gas production is about 2 lakh cubic meter per day. This is the block awarded under the program under round 1 explosion, round 2, round 3, total blocks 26, area awarded, total CBM resources, CBM well steel. These are the some of the figures that is available from the Ministry of Coal. Types of the coal, because we are having the different types of the coal, and the coal is classified into various grades based on the composition, calorific value and degree of the qualification that has occurred during its formation. Coal may be also classified as hard or soft coal, low sulfur, high sulfur coal. Coal may be also classified in rock types based on the petrological components known as martial. Based on the martial content, coal may be classified Clarine, Durine, Fusion and the Whiten. One general classification of the coal that is everywhere that is given in the form of the peat, lignite, subbituminous, anthracite coal, like that. So we will be discussing about the classification, general classification that is given. You will find the peat is the precursor of the coal form. In the initial it is in the form of the peat, and from conversion is taking from the peat to lignite, and lignite is subbituminous to bituminous, and then the anthracite. So peat is the precursor of the coal form. Lignite, with a further increase in the temperature during the coal formation, peat is converted to lignite. Lignite is considered as immature coal. Lignite are brownish color, soft, low calorific value. It is compact in texture. Subbituminous coal are black colored and are more homogeneous in appearance, and their properties range from lignite to those bituminous coal. Bituminous coal is usually black with the high carbon content and calorific value. Anthracite coal is highest rank coal, is a harder, glassy black coal and highest content of the carbon and calorific value. Anthracite coal is the best suited for making metallurgical coke, for gasification to produce synthesis gas, and for combustion as fuel for power generation. The S content is also low. Graphite is the highest rank and is difficult to ignite. This is the typical coal characteristics in selected Indian power plants compared to selected Chinese and the US coal. Composition of the carbon, hydrogen, nitrogen. You see the carbon content, that may be the around 25 to 62 in China. So this is one of the advantage in case of the China, because the carbon content that is very high. Selection of the coal for various application depends on its composition and carbon content, calorific value, moisture content, ash content, composition of the ash, fusion temperature of ash, coking quality, sulfur content. Assessment of the coal quality. Coal quality plays an important role in the efficient utilization as fuel and for gasification. It should have high calorific value, high carbon content with low ash content. It is always desirable, otherwise the whole economy of the process that will be affected. Low sulfur content, low moisture, low cost. The quality of the coal depends upon its rank. The coal rank is arranged in the ascending order, that the lignite, subbituminous, bituminous coal and the anthracite. Coal quality can be assessed by proximate, because these are the two methods that we are using for the assessment of the coal quality: proximate and the ultimate analysis, and the calorific value. Proximate analysis involves the determination of the moisture, volatile matter, ash and the fixed carbon. Ultimate analysis involves determination of the carbon and hydrogen, nitrogen, sulfur, oxygen. Calorific value, the lower calorific value, higher calorific value, these are the grass calorific value, these are the some of the measurement of the calorific value, and then the useful heating value. Coal as a fuel, because as I told you earlier also, major portion of the coal we are using as a fuel and for the power generation, but coal other routes are also available that coal can be used as a liquid fuel also. Coal accounts for the 53% of the commercial energy sources in India, which is high compared to the world average of 30%. The 11th plan projects India's coal demand to grow at 97% per annum against 5.7% during the 10th plan, almost twofold increase. The commercial coal in India is mainly consumed by the power sector, steel sector and cement. So you can say the major share is the power plants, steel plant and the cement. Allocation of the coal blocks to the private companies for the power sector: 20 blocks, iron, steel, small and isolated cement plants and ultra mega power projects. Now we will be discussing about the coal as a chemical feedstock. Why the importance of the coal as a chemical feedstock? Because you see the coal originally was utilized as a fuel for the production of the when the gases, you must be knowing about the producer gas, town gas, blue gas. These were the some of the through the gasification route that was being used. Many of the petrochemicals now derived from the petrol and natural gas was earlier derived from the coal and especially from the coke oven plants, because the aromatics earlier benzene, toluene, xylene, the aromatics and a large number of the other organic chemicals are present in the coke oven gases. We are getting either through the coal tar distillation or the separation of the benzene, and so these are that was the important source of the aromatics during this. Only thing that in case of the coke oven plant, the yield of the aromatics that is comparatively low. With the starting of the coke oven plants, it became source of organic and some inorganic chemicals, because during the coke oven plants or the coke oven gases, they also contain the ammonia, and that ammonia that is being utilized by steel plants for making of the either ammonium sulfate or the ammonium nitrate. Coal tar from the coke oven plants continues to be the source of aromatics, naphthalene and other valuable aromatics like pyridine, picoline, quinoline. This is the only the selected list, the important actually the aromatic. Apart from the large number of the aromatics are present in the from the coal tar that we are getting in the from the coke oven plant. Before coming of the petrochemical production, large number of the organic chemicals were produced from the acetylene produced from the calcium carbide route, in which coal was a important feedstock. China has come in a big way for production of the chemicals from the coal because of the huge coal reserves and the better quality of the coal they are having. With the rising cost of the crude oil and dwindling crude oil reserves, coal has again received attention all over the world to utilize coal as an alternative source of chemical feedstock, not only in the developing country, in the developed country, but also in India we are working to utilize the coal for the production of the chemicals through the gasification route. Various routes for the production of the organic and inorganic chemicals, coal carbonation and the coal tar distillation, coal gasification, use of synthesis gas as feedstock for ammonia production, coal liquefaction by hydrogenation, acetylene from the calcium carbide. These are the some of the technology which has come during the recent year and getting importance in utilization of the coal, that is the coal to methanol technology, because that is the in intermediate is the also of course the production of the synthesis gas, and from the synthesis gas to methanol. Coal to olefin technology, because the methanol to olefin technology or coal to olefin technology, because again it is the from the coal to methanol and methanol to olefin. Coal to plastic, this is also the from the coal to olefin, and these olefin are being used for the making of the plastic. Already China they are going to have a plant based on the coal for the production of the plastic. Acetylene from the calcium carbide made from the lime and the coal, and the various chemicals from the acetylene. We are getting a large number of the chemicals from the acetylene which were earlier manufactured from the petrochemical route. Now you see this is the how the various process involved and what are the actually the products we are getting, and the various coal chemicals, a long list is there. Coal carbonization, high temperature, low temperature carbonization, because two types of the carbonization we are taking, and we are getting the coke and the gases and the coal tar that we are using for the production of the your various actually the inorganic and organic compound. Ammonium sulfate, that is one of the very important part of the any steel making plant, because in many of the steel plants they are making the ammonium sulfate or ammonium nitrate, pyridine based ammonium thiocyanate fuel gas, then the solvent naphtha, benzene, toluene, xylene, indene, all this actually cyclopentane from the light oil or the from tile, pitch coke, road tar, crude naphthalene, because naphthalene earlier it was the route for making of the phthalic anhydride. Now we are making the phthalic anhydride through the orthoxylene route. and then the coal gasification, of course the synthesis gas, and through the synthesis gas ammonia, methanol, oxosynthesis, Fischer-Tropsch synthesis conversion, tar and oils for the phenols and the cresols. Coal based fertilizer plant, because as I told you, the coal that has been a very important source for this manufacture of the synthesis gas, and the coal gasification use of the synthesis gas as feedstock for production of the ammonia has again received attention, because two units we are having earlier, and we started the manufacture of the ammonia and the urea at our Ramakundan and the Talcher plant of the FCI, which was later on closed because of the because large number of the fertilizer plant they came based on the natural gas or the naphtha, and they were more economical. So, partial oxidation of the coal is used for production of synthesis gas and ammonia. CO from the partial oxidation is converted to CO2, which is used for the urea manufacture. That is the process we are using in case of the ammonia manufacture and the urea manufacture. Synthesis gas is used as chemical feedstock for production of large number of the chemicals. Coal gasification, that has become one of the important source for producing fuel and the synthesis gas. Coal gasification, production of the fuel from Fischer-Tropsch synthesis getting significant attention during recent years. Coal gasification, production of synthesis gas is now considered to be a major potential on-purpose source of commodity petrochemicals, which are now being produced through the crude oil route or from the petroleum base. Coal gasification, the cost of the coal and higher cost of the chemicals derived from the coal has been major constant in its utilization as substitute of the petroleum and natural gas, because the synthesis gas which we are getting from the naphtha or the natural gas is much cheaper. Even the cost of production, if you compare the fertilizer plants which is based on the coal and the fertilizer plant based on the natural gas, that is the cost is more in case of the coal than the natural gas. It is just in the descending order. If you take the natural gas, then naphtha, then the coal. So, the much higher cost of production is there in case of the coal, and especially in Indian condition because of the high S content, that is also one of the reason for the high cost. This is in brief about the various products which we are getting from the synthesis gas, and so the methane, natural gas and naphtha you are seeing, but one source from the coal you see from the coal, because this actually the various product from the synthesis gas that we will be discussing while discussing about the petrochemical processes in the synthesis gas and chemical. But in brief here just you can see the from the coal gasification route you will be getting the synthesis gas, and from the synthesis gas a large number of the product chemicals that can be generated, that the methanol to formaldehyde, acetic acid, dimethyl terephthalate, MTB, solvent, chloromethane, fuel, because the methanol blend that can be also there. Now the methanol is coming in a big way in the as a fuel cell. The production of the CuNH2, that is the raw material for the formaldehyde, acetic acid, ethylene. Hydrogen and nitrogen, again this is also called sometimes synthesis gas, and this is for the production of the ammonia and the urea. Hydrogen that you can separate from the CO2 after conversion of the CO2 CO2, and that CO2 that is being used in the fertilizer plant, or that will be sometimes it is creating problem, gasification or the even in case of the starving, because during the production of the hydrogen about 10 tons of the CO2 is also produced. If you are not having the use of the CO2 in the process, then that will create problem. CO, based on the CO, these are the some of the chemicals, acetic acid, acetic anhydride, propionic acid, acrylic acid. These are the some of the major actually the chemicals which are producing from the CO or the synthesis gas. Coal conversion technology, coal gasification, coal liquefaction, that may be direct liquefaction or the solvent extraction, where we are adding the solvent and hydrogen. Indirect liquefaction, Fischer-Tropsch synthesis, that may be again high temperature and low temperature. Carbonization, pyrolysis of the for coke making. As I told you earlier also that the calcium carbide and acetylene, that was the major source of making many of the chemicals, or now we call it the petrochemical, because there was no petrochemical. If you see when we started the petrochemical refinery, it was in the beginning of the 19th century. It was the 1920 that some of the petrochemical we recovered from the refinery. So earlier, before coming of the petrochemical complex, it was the calcium carbide, and from the calcium carbide to acetylene, and acetylene that was being used for the manufacture of large number of the chemical. So this is the process how the calcium carbide and calcium carbide to acetylene production is there. From after adding the water, you are producing acetylene, and this CO again we are regenerating. These are the some of the product we are getting from the acetylene: vinyl chloride, polyvinyl chloride, acrylonitrile, acrylic fiber. Because earlier when the cracker plant was not there, because now we are making the vinyl chloride from the ethylene which we are getting from the cracker plant. Earlier it was the vinyl chloride from the acetylene route that was being used for the polyvinyl chloride, and now still one plant, Serum Chemicals and Fertilizer at Kota in India, they are using the acetylene route for production of the vinyl chloride and polyvinyl chloride. Acrylic fiber, again acrylic fiber was because acrylonitrile that was made from the acetylene route, and so the acrylonitrile produced from the acetylene that was being used earlier for the acrylic fiber. But now acrylonitrile we are having with the coming of the propylene, now we are making to the petrochemical. Vinyl alcohol, vinyl fluoride, vinylidene chloride, acrylic acid, methyl methacrylate, acetaldehyde again because normally we are making through the ethylene or the alcohol route, but earlier it was through the acetylene route technology available. Vinyl ethers, 1,4-butadiene, chloropene. For the chloropene also the acetylene route is available, chlorinated solvents. Coal to methanol technology, the process involves the production of synthesis gas from coal via partial oxidation followed by conversion of the synthesis gas to methanol. This is the technology that is being used for the production of the methanol. Again we will be discussing in detail about the production of the methanol from the synthesis gas while discussing about the petrochemicals in module 7. Coal to olefin technology. Methanol from synthesis gas from coal gasification can be converted to dimethyl ether using bifunctional catalyst, which can be used as a gasoline blend, or methanol can be converted to olefin by MTO process. This process produces ethylene and the propylene. Olefin synthesis from synthesis gas via dimethyl ether to olefin process, that is also SDTO, that is also available. Olefin produced from the coal route can be used for the manufacture of polyolefins, and that is the polyolefin plastic. Propylene can be manufactured from methanol to olefin technology. Propylene from MTO can be used for polypropylene. Coal to plastic technology based on coal is getting important. China is already going to have one commercial plant for making polyethylene and the polypropylene from the coal route. Major constant in coal to chemical route. Variation in the coal quality which affect the efficiency and the economics of the gasification. Changes in the syngas composition due to variation of the coal quality, because you see the coal quality that is varying very widely from one place to another, one source to another source, and so the quality, even the just you take the case of Assam coal, although it is having high carbon but very high sulfur content. Some of the coal are having very high ash content. So changing in the syngas composition due to the variation in the coal quality is there. High ash content of the coal, as in case of India, high sulfur content, impurities present in the coal may be detrimental as they may affect the catalyst and the process, because the catalyst poisoning that may be there because of the some of the impurities which are present in the coal. Environmental considerations such as sulfur content and CO2 emission which is there in case of the your coal gasification route. Mercury emission, that is one of the another problem that we are having in case of the coal, because some of the coal they are having the high mercury, and so because of the mercury emission, now that has been made mandatory for all the thermal power plant to monitor the mercury content of the coal. So this was about the coal and the coal as the chemical feedstock. In the lecture 2 of the module 2, we will be discussing about the coke oven plant, because that was the starting of the production of the chemicals which now we are seeing through the petrochemical route.